Hello, welcome back to another session with Professor Saltos. This is a flash moment with Professor Saltos. Okay, so I have a new request for the week. We're going to be looking at a little bit of an advanced problem on quantum numbers. And I'm going to be sharing this document with you so that you can see our question. So we have this question, number 6. It says an atom of an element number 33, arsenic, is in its ground electronic state. Which one of the following sets quantum numbers could not apply to any of its electrons? So far we have seen that, when we have sets of quantum numbers, we want to make sure of which one actually makes sense, right? Which ones are there and that make sense. So you could take number 1, for example, and start figuring this out, right? You will say, okay, if I have n equals 4, what are my possible L's, right? My possible L's, well, remember that for L, it's in a range of 0 to n minus 1, right? So my possible values for L could be 0, 1, 2, and 3, right? Because 3 is 4 minus 1. So this being said, right, we have if our L equals 0, right, the only possible ML is 0. So this actually makes sense, right? But I'm looking at this and we can go ahead and check every single one of them, right, to make sure that whether it works or not. We have n equals 3. So our L's could be 0, 1, and 2, and so far, right? For our ML, remember, is the negative L to 0 to positive L, right? This is the range. So for the L equals 2, right? ML could be negative 2, negative 1, 0, 1, and positive 2. So again, this makes sense. And obviously, right, we have for all the MS, it's just plus or negative 1 half. So that is okay. Right, but we see C, also works, D also works, and E also works, right? Because again, we have for, say, for example, for C, where we have n equals 4, L can be 2, yes. ML can be 1, yes, right? Because it goes from negative 2 all the way to 2. In D, the same thing, n equals 2, L can be 1, right? N minus 1, that's 2 minus 1. So it can be 1, so ML can be 1. For E, same thing. So what do we do, right? So actually what we have to look is pay a little more attention to that question. Which one of the following set quantum numbers could not apply to any of its electrons, right? And we're talking about arsenic, to any of its electrons. Okay, so now I'm thinking, okay, what do they mean by any of these electrons? So, well, first off, I will have to see what its electrons look like, right? And to do this, right, and to know, since we're talking about quantum numbers, we have to talk about location, right, and position of the electron. So one thing that can help us greatly is do the electron configuration for arsenic, and then we can figure some things out. We have 33 electrons, so we're going to start building our electron configuration the way that we have practiced. 20 for F2, 3D10, that's 30, and then I do 4P6. Oh, 4P3, sorry. Right? Because remember, we have only 3 electrons left at the end, right, for 33. So it's 4P3. Now that I have this, let me see if I'm able to put this set of quantum numbers in this form, in this notation. So for 4A, right, if, remember, we put our first number, that's a principal quantum number, so it will be 4. And L, right? For values of L, we have, this is the S shape, P shape, D, and F shape, right? Right here on the top. So for L equals 0, this is a 4S, and yes, we do have a 4S, so this can apply, right? This can apply. For B, we have a 3D, right? L equals 2, so that will be corresponds to the D orbitals, and we have 3D orbitals over here, so that's good. We're looking at C. In C, we have 4, right? And L is D, so we have 4D. Now, do we have a 4D orbital? No. Okay, so we do not have it. So that means that this set of quantum numbers cannot apply to any of the electrons in arsenic, right? Because the electrons in arsenic will correspond to any of these orbitals. Just to check, let's see what D is, right? We have principal quantum number 2, L equals 1 is P, and yes, we have 2P, and the last one is 3 with S, right? L equals 0 is S, and we do have 3S. So the only one that we do not have is the 4D orbital. Thus, this is the set of quantum number that cannot apply to any of the electrons in arsenic. I hope this helped. If you have any doubts, please do not hesitate to go back and review quantum numbers, review electron configurations, and don't forget, subscribe to this so that you can be aware of when I post new material. And in the comments, you can request any topic, any questions that you might have that I might be able to help you with. Okay? Have a great day. Thank you for watching.